Welcome back to Math Solver 1117. Have you ever wondered how NASA sends rocket to space with pinpoint accuracy? The secret lies in vectors, a simple, powerful concept in mathematics. Today we will explore how NASA used vector calculation in space mission. So first of all, we will discover what are vectors. So, vector is a quantity. Vector is a quantity that has both magnitude and direction. It has both magnitude and direction. And examples of vectors are velocity, force, displacement, acceleration. These are the vector quantities, and vector is represented by an arrow. Tail of the arrow represent the magnitude and head of this represent the direction. So this is the mathematical way to represent a vector. Now we will discover about NASA challenge, that how NASA sent rockets in space. So we will draw first of all diagram to represent. Let's suppose this is our earth and a rocket is launched from earth to Mars. Then we will say that when NASA launches a spacecraft to Mars, it's not just pointing and firing. They must consider first of all Earth rotation, that how Earth is revolving. They consider this point. Second one is gravitational pull, how Earth attracts gravitational pull. And the third one is most important, and the orbital path of Mars. Orbital path of Mars, this is also considered. And all these factors are represented by using vector like gravitational pull towards Earth, and its direction goes upward. So these are the basically forces that are acting on this, and these are represented by arrows. So how NASA will discover vector calculation? Represent by the vector addition. Let's suppose this is the first vector, this is the second vector, and the third vector will be start from the first to third. This will be the resultant. This is the vector 1 and this will be the vector 2. So by the head to tail rule, we will represent these three vectors, and these vectors are basically the forces that are acting like rocket thrust. These are the forces that are rocket thrust, gravity, force of gravity, and the planetary motion planetary motion, and we will represent by using vector addition. Now the rocket thrust force will be push the rocket forward, force of gravity pulls it downward, and the planetary motion will be make it towards the actual path. So we will get the actual path by the resultant vectors. Now I will explain some real examples. First of all is satellite orbits. Satellite orbits, that vectors calculate the satellite orbits correct orbital speed and direction. We will get speed and direction with the help of vector. And the next one is we will discover the Mars rover landing vectors guide about the entry angle to avoid burning or missing Mars. These are the two real examples of how NASA used vector calculation in space mission. So next time when you hear about a NASA mission, remember behind every successful launch there are millions of vectors calculation guiding the way. If you enjoyed this video, hit like, subscribe for more amazing math in real life, and comment below which space mission should I explain next with maths. Best of luck for your exam. Stay tuned.